Hello everyone, welcome to my channel WishInfinite. Now we are going to understand equations, inequalities and polynomials, three important building blocks of algebra. These are fundamental mathematical concepts that will make many upcoming topics much easier to understand. Now let's first start with the equations. So what is an equation? An equation is a mathematical statement that shows how expressions are equal using the equal sign. The goal of solving an equation is to find the value of the unknown variable that makes both sides equal. Here is one simple example of equation: x plus 5 equals to 12. And here we are using this equal sign. So what does the equal sign means? Equal sign means left side equals to right side. So think of an equation like a balance scale. If both sides are equal, the balance remains stable. Now let's see some examples for equation. After that, we will also talk about parts of an equation. And then we will see how to solve equations. Now let's first see some simple examples for equations. So here we just saw x plus 5 equals to 10 is an equation. Similarly, we can write y minus 3 equals to 7 is also one equation. Similarly, we can also write 2a equals to 20 is an equation. And like this, there can be multiple examples. And here if you will notice, we have used this equals to sign between these two expressions, right? Here and here. So here left side is equals to right hand side. Now let's take one real life example. Suppose you have 200 bucks and you spend 50 bucks. How much money remains? So let's say remaining money is x. So how we can make an equation for the same? So here we can write x plus 50 equals to 200, right? We were having 200 bucks and out of which we have spent 50 bucks. So we have this much remaining amount. And here we can also solve the equations to get the value of the variable. So here the variable is x. How to solve the equation, I will tell you in detail. But for now you can understand it like this. We can solve it equation by writing x equals to 200, which was the total amount, minus 50, which we have spent. So how much is left? 200 minus 50 is 150. So here value of x will be 150. So this is how we can solve the equation. In some time I will tell you in depth that how to solve these equations. But before solving an equation, let's see what are different parts of an equation. So here let's take one example. So let's say our equation is 3x plus 5 equals to 20. Now here this x is a variable. These 5 and this 20 are constants. Here this 3, which is attached with this variable x, is coefficient of variable x. What is coefficient? That I have already told you in my previous video. Coefficient is the number which is attached with the variable. Here this plus minus will be mathematical operator. And then we call this whole section is a mathematical expression. Mathematical expression contains multiple terms. So this is one term. This is second term, right? Each term is separated by plus or minus. And then we have this mathematical equation, which is 3x plus 5 equals to 20. So this whole thing is called mathematical equation. In previous video in detail, we have seen that what is mathematical expression. Now we are talking about mathematical equation, right? This part is mathematical expression. This part is mathematical expression. But when we combine mathematical expression with the equals to sign, it becomes mathematical equation. Now we know different part of mathematical equation. And what is mathematical expression? That I have already told you in my previous video. If you have not watched that video, I would highly recommend you to watch that video. You can click onto this I button at top right corner to access that particular video. Now let's talk about solving equations. So let's take one example here. So let's say we have an equation which is x plus 7 equals to 15. So now how to get value of x? So solving an equation means how to get value of variable. So here the variable is x. So we want to get the value of x. And how to do that? So our goal is to get this variable x alone. Currently it is with this plus 7, right? At the left hand side. But we want to get this x alone. How to do that? So for this particular equation, there is a simple way. So we can simply subtract 7 from both the sides. So we will subtract 7 from here. So what we will get? Only x. And if we will subtract 7 from this side, we are going to get 8. So here we can write it like this. X plus 7. And here we are going to do minus 7. Then equals to 15 minus 7. We are going to subtract 7 from both the sides, right? So that's why we have written this minus and then 7. So from this side, plus and minus 7 will get cancelled out, right? This and this. What we are going to get? We are going to get x. And from this side, which is at the right hand side, what will happen? 15 minus 7, which is 8. So here we can write x equals to 8. And now we have got the value of x. X is 8. You can simply validate this value also. If you will put 8 at base of x, so 8 plus 7, which is equals to 15, right? So 15 equals to 15. Left side equals to right side. Now let's see one more simple example. So here we have the equation which is x minus 4 equals to 10. Now how to solve it? Pause the video here and think about it. So to solve it, what we can do, we can simply add 4 at both the sides. So here we can write x minus 4, which is this one, and then we want to add 4. So here what we can write, plus 4, then equals to, and here what we can write, 10, and here also we want to add 4, so plus 4. Remember, we need to do the same operation at both the sides of equals to sign. Again here this 4 will get cancelled out, right? 4 with this 4. Or plus 4 minus 4 is going to be 0, right? So we need not to write x minus 0. It is going to be x only. So now here what we can write, x equals to, and then this 10 plus 4 equals to 14. So we have got value of x. It is 14 for this particular equation. Here you can revalidate it also. 14 minus 4 equals to 10, right? So 10 equals to 10 you will be getting. Let's see one more example. I am taking multiple examples so that you are aware that how to solve different type of equations. For now I am just taking very simple examples. So here let's say we have one more equation which is 3x equals to 18. Now how to get the value of x? Previously we have seen that we were having the equation where we were having addition, subtraction, but now we have this multiplication. 3x means 3 is multiplied by this x. This multiplication is hidden, right? You need not to put that multiplication sign, right? It is understood only that we are going to multiply this 3 with the x. So now how to get value of x? Here we are multiplying it, right? 3 with the x. And what is our goal? We want to leave this x alone. And how to do so? So now what we can do to get this particular x alone, we can simply divide it by 3 at both the sides, right? So if we will divide this particular expression by 3, so 3 by 3 it is going to be 1. So 1x means x, right? So our x will be alone. And you can remember it like this, right? Whatever the operation which this particular expression is having, you need to do it supposite. So here previously we were having x plus 7. So that's why we have subtracted it with the minus 7. Here we were having x minus 4. So that's why we have added it with the plus 4. And similar thing we are going to do here. Here it is multiplication, which is 3 multiplied by x. So now we are doing opposite of multiplication, which is division. And we need to do this particular operation at both the side. Then only we will be able to maintain this particular equation, right? Because we are having this equals to sign. So while solving whatever the operation which you are doing, you remember that you need to do it at both the sides, right? So here now let's divide it. So it will be 3x. And here to divide it, let's put this and then 3. Again equals to 18 divided by 3. You can use this particular symbol also. For now, I will do it like this. So 18 divided by 3, right? At both the sides, we are dividing it by 3. Now this particular 3 will get cancelled out, right? 3 by 3. So what we are going to get? We are going to get 1x. And we can simply write this 1x as x, right? So this is our left hand side. At the right hand side, what will be happening? So let's put equals to sign. And here 18 divided by 3 is going to be 6. So we have got value of x as 6. And I told you, you can revalidate it if you will put value of x here into this particular equation. So what we are going to get? 3 into 6, which is 18. And 18 equals to 18. So hence proved. And for now, we have seen very simple example where we were having only one operation within the expression. Here it was addition of variable and constant. Here it was subtraction. Here it was multiplication. But there can be multiple operation for equations. Now let's consider one example, which is 3x plus 5 equals to 20. So now here we are having this addition as well as we are having this multiplication for this particular expression. Now how to solve these two operations, right? If it is only x plus 5, we would have subtracted 5 from both the sides. But here we are having this addition as well as this multiplication. So in this case, we will have to follow one simple rule that I've already added into the document also. So usually whenever you have some mathematical expression, let's say it is 3 into 3 plus 4 minus 2 into 18 divided by 3. And to evaluate it, we follow one simple rule. First we solve the parentheses, then exponents, then multiplication and division, and at the end we solve this add and subtract. So this rule we are using from very starting, right? Whenever we want to solve any mathematical expression, we simply use this particular rule. But now we want to solve a mathematical equation, and for that we just need to reverse this particular rule. And the reverse rule is this one. First we need to solve this addition and subtraction, and then multiplication and division. After that we need to solve exponents, which means powers or roots, and at the end we need to solve parentheses. So whenever you are solving such kind of mathematical equations, you need to follow this reverse order. Addition, subtraction, multiplication, division, then exponents, and then parentheses. Let's see the practical example for the same. Now let's apply this particular rule for our equation. So this is our equation, which is 3x plus 5. So here we are having addition and then multiplication. And we just saw the rule that first we need to solve addition or subtraction. So here we are having addition. And after that we are having multiplication. So then we will be solving this particular part. Let's see the practical example. So to solve this addition, what we need to do? So we saw that if we are having addition with our equation, we just need to subtract it from both the sides. So here what it will be? It will be 3x plus 5 and then minus 5. And at the right hand side, so put equals to, then 20 minus 5. So now what will happen? Plus 5 minus 5, which will be 0. So we can write 3x and then equals to, and here it will be 20 minus 5, which will be 15. And now we have solved addition. Now we need to solve this multiplication as per our rule. And how to solve it? We can simply divide this 3 from both the sides. So here we will be getting this x alone. So how to write it? 3x, which is 3 multiplied by x, then divided by 3 equals to 15 divided by 3. And now what we are going to get? We will get x equals to 5. So this is how we can solve mathematical equation which is having multiple operations. And there can be multiple permutation and combination for these equations. You can have addition and multiplication. You can have division and subtraction. You can have division and addition. You can have addition, multiplication and exponents, right? So you need not to be worried about that. You just need to follow this particular simple rule. That first you will be solving addition and subtraction, then multiplication and division, then exponents, or you can call it power or roots, and then parentheses. That's it. Let's see one more simple example. So here let's say we have this x square plus 2 equals to 27. Now how to solve it? So we just saw the rule. First we need to solve this addition or subtraction. So here we can simply first solve this addition. How to solve it? Again you can do the subtraction at both the sides. And usually I follow one shortcut. Rather than doing the operation at both the sides, we can simply move the value. So here what we can do, we can move this plus 2 to this particular side. And while moving, its sign will get changed. So if it is plus 2 at one side, it will be minus 2 at the other side. If it is minus number at this side, it will become plus at this particular side. So here simply what we can write, x square equals to 27. And then here we are moving this particular plus 2 to this other side, right? So it will be minus 2. Which will be x square equals to 25, 27 minus 2, right? Now again, our final goal is to get the variable alone. Still it is not alone. It is having power, which is exponent, right? What is exponent? That also we have seen into the previous video. Again, you can click onto this I button at top right corner to get that particular video. Now how to get this x alone? X square means x into x also you can say. And opposite of square will be square root. To solve these things, we saw previously also that we need to do the reverse operation. If it is addition, we need to do the subtraction. If it is subtraction, we need to do the addition. If it is multiplication, we need to do the division, right? And here, it is exponent, right? Or the power, so we need to do the opposite, which is root. It is a power of 2, so we need to do its opposite, which will be square root. So how we can write it? We can simply write it like this, right? You can write it into the second line also. So now what will happen? This square root will cancel this particular square. So now what we will be getting? We will be getting x here. And at the right hand side, square root of 25 will be 5, right? It is a perfect square. What is perfect square? That also we have talked, right? So if we will multiply two numbers, we get this perfect square. And square root of perfect square will be integer only. So in this case, square root of 25 is going to be 5. So if we will do 5 into 5, it is going to be 25 only. So here we can write x equals to 5. And now we have got our answer. that x is equals to 5. So in our equation, which is this one, value of x should be 5. Now we can prove it also. So here you replace value of x with this 5. So what it will be? It will be simply 5 square plus 2 equals to 27. And now 5 square means 5 into 5, which is 25 plus 2 equals to 27. Again 25 plus 2 means 27 equals to 27. So left hand side equals to right hand side, hence good. Again, let's go one step further with different example. So here let's say we have an equation which is x plus 2, and then we need to put a square for this whole expression. So here I am putting parenthesis and then square. So it is square of x plus 2 and then equals to 36. And now we need to get the value of x. So how to solve this particular equation? For this also we need to follow that simple rule only. What was our rule? So here first we need to solve this addition and subtraction, then multiplication and division, then exponents, and then parentheses. So now here what we are having? X plus 2 and then its square. So now you may be thinking that first we need to solve this x plus 2. But that is not the case. Let's have a look at our rule in more detail. So here we are having square of x plus 2. So this x plus 2 is written inside a parenthesis. And here if you will look at this particular rule, you will see that we need to solve the parenthesis at the very end. Although this particular parenthesis is having this addition, but we need not to touch it. We need to touch this particular parenthesis at very end. So before the parenthesis, what we are having? We are having this exponents. And in our expression, we are having this particular square, right? Which is exponent. So first we need to solve the exponent and then we will be solving the parenthesis here. And to solve the exponent or the power, what we need to do? So here we are having power of 2. So to cancel it out, what we can do? We can put a square root at both the sides. So now here what will happen? X plus 2 and then we are having this square and then we can put a square root here. Again at the other side also we need to do the same. So equals to and then square root of 36. And here this particular square root and this square will get cancelled out. So what we are going to get? We are going to get x plus 2. You can put this parenthesis for now. And then at the right hand side what will happen? Square root of 36 is going to be 6, right? 6 into 6 equals to 36. It is also a perfect square, so we can write it as 6. And now we have this parenthesis, so we can solve whatever which is there inside the parenthesis. So inside the parenthesis what we are having? X plus 2, right? So now we can remove the parenthesis and we will solve this. And here we can write equals to 6. Now again main goal is to get the x alone. And how we can do so now, right? You should be aware. We just need to simply do the subtraction at both the sides. And here to get this x alone, we need to do the subtraction with the 2. So x plus 2 minus 2 equals to 6 minus 2. Or you can simply move this plus 2 to the other side. So you can write it like this: x equals to 6 and then this plus 2 will go to the other side and it will become minus 2. So the same thing is happening, right? Here that plus 2 minus 2 got cancelled out. So we are seeing nothing. And here again also we are doing that subtraction, which is 6 minus 2, which is 4. So x equals to 4. I am following this particular shortcut. If you want to do the opposite operation at both the sides, so feel free to do that, right? Although same thing is happening, just one thing is that you will not have to write it down. You are just simply moving this value to the other side, and in that case its sign will get changed. If it is plus, then it will become minus. If it is minus, it will become plus. If it is multiply, it will become division here. Or just to keep the thing simple, you just do the opposite operation at both the sides. So here it will be minus 2 and here also it will be minus 2 and you will get your answer. And like this you can solve any of the equation. You just need to follow this particular simple rule. Until now we have seen the equations which are having variables at only one side only. See here what are all the equations which we just saw, that we are having all the variables at the left hand side only. But we can also have the variables at both the sides. So in that case how to solve it? Let's see that also. So let's say we have an equation which is 3x plus 5 equals to x plus 15. Now how to solve this particular equation? You already know our main goal is to get variable alone. For now we are having our variables at both the sides with other values also, like we are having constants here. So now to simplify this, where we are having variables at both the sides, what we can do? First we can move the variables at one side. So here what we can write this 3x, and let's move this particular x to this particular side. So previously with the constant also we saw that if we will move something to the other side, its sign will get changed. So here it was plus x, now if we are moving it here, so it is going to be minus x. So 3x minus x. And here still we are having this plus 5. And now we have already moved this particular x to this particular side, which is this one. So we need not to write it here. So now here what we can write? We can put equals to and then 15. And now this 3x minus x, what it will be? So we can simply subtract this 3 with 1. Why 1? Because it can be written as 3x minus 1x. If it is 1, we need not to write it, but just to simplify it, I am showing it to you. Usually we need not to put this particular 1. You can simply do this 3x minus 1x, which is 2x, or you can do this 3 minus 1, which is 2, and then you can put this particular variable, right? It is just the different ways, right? For now I will remove this 1, right, as we need not to write it. What we can do simply this 3 minus 1, which is 2, and then we can put the variable. So here it will be 3x minus x, which is 2x. So in place of this, let's write 2x. So 2x and then plus 5 equals to 15. And now we need to solve this addition first. So again you can do the opposite operation at both the sides, which means minus 5 here and minus 5 here. So minus 5 and plus 5 will get cancelled. So what we are going to get? We are going to get 2x. And at this side what will happen? 15 minus 5. Right? It will be 15 minus 5, which is going to be 10, right? So here we can write 2x equals to 10. And now again we need to get this x alone. So how to solve it? Now after the addition we can solve this multiplication. For that we can simply do the opposite operation, which is divide the 2 at both the sides. Or as I told you that we can follow the shortcut, that rather than doing this division at both the sides, we can simply move this particular 2 to this side. And when we will move, what will happen? Here it is multiplication. So when we will move it at the opposite side, it will become division. So it will not happen that if you are moving this particular 2 at this particular side, so it is going to be 10 multiplied by 2. It is going to be 10 divided by 2. Here it is multiplication. So now it will go here and it will become division. So now we can write it x equals to 10 divided by 2. Or just to keep the thing simple, if you are getting confused, just do the opposite operation at both the sides. Here also the same thing is happening. 2 divided by 2, we have already got the x, and here 10 divided by 2. So here what we are going to get? We are going to get x equals to 5. This is how we can solve our equation. Here if you want to do the cross verification, that also you can do. Just put value of this x as 5 into our equation. So let's do that quickly. So here what we can write? 3, and here on place of this x what we need to put? We need to put this 5. 3 multiplied by 5, right? I told you that we need not to put the multiplication sign. Automatically we are writing it like this. We can consider that it is 3 multiplied by x. So we are doing this 3 multiplied by 5, and then we have this plus 5. And at the right hand side also we were having this x. So value of x is 5 and then plus 15. And now this is our basic mathematical expression. How to solve it? That also we just saw that we need to follow this particular order when we are evaluating the expression. So here we are having multiplication and addition. So in this case we will be first solving this multiplication and then this addition part. So here what we can do? 3 into 5, which is going to be 15. So here we can write 15 plus 5 equals to 5 plus 15. Now we have already got the equal things, right? 15 plus 5 equals to 20. And here also it is 5 plus 15, which is 20. So now both the sides are equal and hence proved, right? This value of x is 5, which is correct one. Because we have got both the sides equal only. And now we have seen multiple examples for equations. Here in the document in the assignment section, I have added one question for the equations where you need to solve this 4x plus 7 equals to 31. So now solve this particular equation, find the value of x and let me know into the comment section that what is the output. If you are having any doubt also, just let me know into the comments. And after the equations, we will talk about inequalities. So what are inequalities? An inequality compares two values and shows whether one value is greater than, less than, greater than equal to, or less than equal to another value. Unlike equations, inequality usually have multiple possible solutions. So until now we have used equal to sign, meaning exactly equal. But many real-world solutions involve comparisons. For an example, age must be at least 18. Temperature should be below 40 degrees Celsius. Exam marks greater than 40. These are inequalities. Inequality have different symbols. Like for greater than, we have this symbol, which will be open at one side and close at one side. So expression at this particular side where it is open, it should be greater. And expression at the opposite side where this arrow is closed, it should be small. Similarly, we have less than symbol. It is very similar to greater than, but it is opposite of this greater than. So expression at this side where arrow mouth is closed should be small, and expression at this particular side should be greater. Similarly, we have this greater than equal to symbol, where expression at this particular side where arrow mouth is open should be greater than or equal to the expression which is at the other side where arrow mouth is closed. And again we have one more opposite symbol which is less than equal to, where expression at this particular side where arrow mouth is closed should be less than equal to expression which is at the other side where arrow mouth is open. Apart from that, we have one more symbol which is not equal to, where value at the both sides should not be equal. Now let's see some examples of inequalities and how to solve inequalities. Let me open one separate page which is for inequalities. So here we have one example which is x plus 3 is greater than 10. Here we are not using that equal to sign, we are using this greater than symbol, where expression at this particular side where arrow mouth is open should be greater than the expression which is at the other side where arrow mouth is closed, which is this one. So x plus 3 should be greater than 10. Now how to solve this particular inequalities? So it is very similar to the equation which we solved. We need to follow the same rule, right? Where first we need to solve this add and subtract, then multiply and division, after that exponents, and at the end parenthesis. Only at the end, on place of this equal to symbol, we will be having our inequality symbol, which we just saw, greater than, less than, greater than equal to, or less than equal to. Now let's solve this particular inequalities. So here, as I told, we need to follow the same rule and we need to do the same thing only. Now what we need to do, we need to get this particular x alone, and to do that what we'll have to do, we'll have to do this opposite operation. So here we are having this plus 3. So what we can do, we can subtract 3 at both hand side. So for that what we can do, x plus 3 minus 3 is greater than 10 minus 3. Now this plus 3 minus 3 will be 0, so we will be getting x at this particular side, and then greater than symbol, and then 10 minus 3 is 7. And now our inequalities is solved. And here what is the final answer which we have got? X is greater than 7, which means x should be greater than 7. It can be 8, 9, 10, 11 and so on, right? There can be multiple values for x. Only thing is that it should be greater than 7. 7 is also not included. Let's take one more example. So x minus 5, and then it should be greater than equal to 15. And again we need to solve it into the similar way. We need to get this particular x alone. So for that we can do this opposite operation, where we can do addition of 5 at both hand side. Or during equation also I told you, you can move the things at other sides. So here we can move this minus 5 to this particular side. And now we will move this minus 5 to this particular side. What will happen? Its operation will get changed. So currently it is minus, so it will be opposite. It will be plus 5 at that sign. So currently it is subtraction, right? X minus 5. And now if it will go to this particular side, it will become plus 5. So it will become 15 plus 5. So let's do that. If you want to follow that traditional method, that also you can do. That add 5 at both hand side. Same thing is going to happen. So here we can write x greater than equal to 15 plus 5. See, same thing is going to happen. If we will do addition at both hand side, what will happen? This minus 5 and plus 5 will get cancelled. We will get x at this particular side, then greater than equal to symbol, and then 15. And here also we were going to add 5, so it is going to be 15 plus 5, which is 20. So here we can write it like x greater than equal to 20. So here x can be anything greater than equal to 20. Why equal to? Because we are having this greater than equal to symbol. So x can be 20, 21, 22, or decimal values also can be there, 20.5, 23.2, right? So there can be infinite values for x now. Now here we will have one more example. So here we have 3x less than 12. Now how to solve it? We need to follow the same rule like the equation. Here we need to get this x alone. And for that what we would be doing? We can do the opposite operation. So here it is 3 multiplied by x. So we will have to divide 3 at both hand side. Or we can simply move this particular 3 to this particular side. And once we will move this multiplication operation at the other hand side, so it will become division. So it will become x less than 12 divided by 3. Or you can write 12 by 3, right? It's up to you. For now I have written 12 divided by 3. So now what will happen? Again, if you will solve it, so we are going to get x is less than, and 12 divided by 3 is 4. So x is less than 4. So it can be anything. It can be 3, 2.5, 1.8, 1.3, 0 and negative values also. So now we can have multiple values for x. It should be less than 4. It can be 3.9, 3.5 and whatever which is less than 4. Now let's take one more example. Here I am taking multiple examples so that you are aware that how to solve different type of inequalities. So here our example is minus 2x is greater than 10. And now while solving this type of inequalities, we need to be careful. Why? So I will tell you. So here what is our final goal? We need to get this particular x alone. And to get this particular x alone, what we will have to do? We will have to do the opposite operation. So currently we are doing this minus 2 multiplied by x. So the opposite operation will be that we will have to divide with this minus 2 at both hand side. So what will happen? So at this particular side it will become minus 2x divided by minus 2, and at this hand side what will happen? 10 divided by minus 2. And that is where you need to be careful, that when you are multiplying or dividing by a negative number, we need to reverse the inequality sign. So whenever we are doing this minus 2x divided by minus 2, and here also 10 divided by minus 2, we need to reverse this particular inequality sign. So here this minus 2 and minus 2 will get cancelled out. So we will get x alone. And here at this particular side, 10 divided by minus 2 is going to be minus 5. And as I told you that when we are multiplying or dividing by a negative number, we need to just reverse the inequality sign. So previously it was minus 2x greater than 10, but when we are dividing this minus 2 at both hand side, we need to reverse it. So in place of this greater than symbol, we will be having this less than. So what is the final answer which we are going to get? So we are going to get this x is less than, and 10 divided by minus 2 is minus 5. So now again repeating this very particular important rule, that whenever you are multiplying or dividing with the negative numbers, in case of inequalities, so you are going to reverse this particular symbol. If it is greater than, it will be less than. If it is less than, it will be greater than. In case of greater than equal to, it will be less than equal to. And similarly, in case of less than equal to, it will be greater than equal to. So now our final answer is x is less than minus 5. And on top of this, you can revalidate all the answers. Like here we have got x is less than minus 5. So whatever the number which you take for the x, if it is less than minus 5, our this particular equation will be true. So what is less than minus 5? It will be minus 6, right? At the left hand side of the number line, any negative number will be small, right? Minus 7 will be less than minus 5. Minus 8 will be less than minus 5. So here let's consider value of x as minus 6. So now here what will happen? Minus 2 into minus 6 is greater than 10. So here what will happen? If you will multiply this 2 with the 6, we are going to get 12. And this minus minus will be plus only. So you need not to put that plus symbol. And then greater than 10. So 12 is greater than 10, right? Which is true. And like this, you can take any number for the x which is less than minus 5. And it should give you true for your inequalities. Let's say if you will take minus 7, so it will be 14 is greater than 10. And like this, you can try to put different values and see what is happening. And like this, you can validate whatever the inequalities which we just solved. Like here we got this x is greater than 7. So here you can take any value which is greater than 7. So let's consider x is 10. So here if we will try to put value of x as 10, what we are going to get? We are going to get 10 plus 3 is greater than 10. So 13 is greater than 10. Let's solve this one. So here we have got value of x is less than 4. So it can be anything 3, 2, 1 or any decimal value also. Let's consider value of x as 2. So here what will happen for this particular inequality? It will be 3 into 2 less than 12. So here 3 into 2 is 6 less than 12, which is true. Same is the case for this particular inequality also. Here we have this x greater than equal to 20. So we can take any value which is greater than or equal to 20. Let's take 20 only. So here what will happen? Here we are going to get 20 minus 5 greater than equal to 15. So 20 minus 5 is 15 and then greater than equal to symbol and this 15. So this is correct. 15 should be either greater than or equal to 15. So here we have got 15 equal to 50. So this is also true. So like this, you can solve any inequalities and then you can validate it. You need to follow the same set of rules which we have used for the equations. Only one important rule you need to follow, that whenever you are multiplying with a negative number or dividing with a negative number at both end sides, you need to reverse this particular symbol. That is very important. In case of equation, that is not applicable. But when you are solving inequalities, you need to be very careful when you are dividing and multiplying with the negative numbers. And whatever the values which we have got here, we can do number line representation for them. Let's say we have this x is greater than 7. So how we can represent them? So here we have this number line. Let me put it. Now we have 0 here. So here let's put 0. And then we will have 1, 2, 3, 4, 5, 6, 7, 8 and so on, right? There can be infinite values. Below 0 also, at the left hand side, we will be having negative values. So here we can have -1, -2, -3, -4, -5, -6, -7 and so on, right? So now we saw that x is greater than 7. So here how you can put it into the number line. So where is our 7 in the number line? So 7 is here, right? This one. And here the value of x can be anything greater than 7. So it can be 8, 9, 10 and so on, right? It can be 11, 12, 15, 100, 1000 or infinite, right? At the positive hand side, at the right hand side. So here we can put an arrow at this particular side. So it can be till infinite. So in this particular case where x is greater than 7, x can be anything which is greater than 7. So it can be 8, it can be 9, it can be 10 or it can be decimal values also. Like it can be 8.1, 8.2, 8.3, 8.225 or multiple values can be there which are greater than 7, right? So here you will be able to see one solid line, right? Because it can be any decimal values like 8.22225. So that will be the valid value for the x. So here we are going to get solid line like this. So anything greater than 7. Here it can be 7.002, 7.5, right? So here we are going to get our line like this. And this 7 is not included. So here we can put a circle, not the solid dot. And it can go till infinite. Similarly, we have this x is less than 4. So in this case also our values can be anything which is less than 4. It can be 3, it can be 3.5, it can be 2.5, 2, or here also it will be a solid line, right? It can be any value which is less than 4, right? So I'm putting these dots here. And as we can have multiple and multiple of values, so here it will be like a solid line, right? Like this. Because if you will put multiple dots which are below the 4, you are going to get one solid line like this. It is just the representation, right? You need not to be worried about that. But I'm just telling you that how to represent it. And here this 4 is not included. So here we can put a circle at 4 because 4 is not included. If 4 will also get included, you will be putting a dot there also. And we can make it solid till infinite at the negative hand side, right? It can be -4, -3, -7 or anything which is less than 4. So here at this particular side also, we can put a arrow because it can be anything. It can be -1000 or till whatever the negative number which you can think of, right? So you can put this solid line till and right like this, right? And like this, you can represent inequalities onto the number line. Let's take one more example where x is less than equal to -3. So anything which is less than -3, it can be -4, -5, -6 and so on. It can be value of x. So how to represent it? So here we can start putting dots from -3 itself. -3 is also included. Why? Because we are having this less than equal to sign. And it can be anything. It can be -3.5, -3.555 or anything. So if we will put multiple points for the x, it will be like a solid line like this. Where -3 is also included. And here you can put an arrow like this, right? It can be anything which is less than equal to -3. And like this, you can represent anything onto the number line in case of inequalities also. Now as an assignment, you do one thing. You'll have to Google it for the same. You try to represent one value where x is less than 7 and greater than -1. So here it is little different. Our value is greater than 7 and less than -1. So our value can be anything in between -1 to 7. You try to Google it for the same, that how to represent it into the number line. In this case, we are going to get the multiple values, but it will be between -1 to 7 only. Because our value of x is greater than 7 and it is less than -1. So now you try to represent it into the number line and let me know how it went. And now there is one more assignment which you need to solve. So our example is 5y minus 10 less than equal to 20. So now you need to get value of this particular y. You need not to get confused with the variable name. It can be anything, x, y, z, a, b, c, right? So you solve this particular inequality and let me know into the comment section that what is the answer. Now let's move to the next topic and very important topic, which is polynomials. So what is a polynomial? So a polynomial is an algebraic expression made up of variables, constants, coefficients and powers where the exponents are non-negative whole numbers. Polynomials are used to represent mathematical relationships and patterns. So in my previous video when we talked about type of algebraic expressions, so there we talked about polynomials. So there we took a quick glimpse about polynomials, but here we are going to talk about polynomials in more details. So here we saw that polynomial is an algebraic expression made up of variables, constants, coefficients and powers. And as it is an algebraic expression, you will be seeing mathematical operators also, plus, minus. So we already know what are terms in algebraic expression, right? This 3x square is a one term, 5x is one term. So polynomial can have one or many terms. It can be 1, 2, 3 or so on, right? Let's see some of the examples so you will be getting proper understanding. Let me open this new page for the polynomials. So now here we have an example which is x plus 5. So this is a polynomial. We have one more example which is x square plus 2x plus 1. So this is also a polynomial. And I just told you that polynomial is an algebraic expression made up of variables, constants, coefficients and exponents or powers. But here in this particular example, where is power? Here we are just seeing x. But this x can be written as x to the power 1, right? So anything to the power 1 will be that thing itself. X to the power 1, it is going to be x. So that's why you can consider x to the power 1 here. And here you are also not able to see coefficient. A coefficient is a number which is attached with the variable. So here we are only having this x. But here we can also multiply this x with the 1. So it is 1 into x, right? So that 1 is coefficient for the x and here this particular one is power of x. And we need not to put this power of 1 as well as this multiplication thing. So we can directly represent it as x, right? You need not to put all these things. Automatically 1 is getting multiplied with this variable x and also it is having power of 1. So you need not to put both the things, right? Here I have just written it just for your reference. Similarly, we can have one more example which can be 3x to the power 3 minus 4x plus 7. And you need not to get confused, right? These are all algebraic expression and they are having one or many terms. It is having 2 terms. It is having 3 terms. This one is also having 3 terms. And it can have more terms or less terms, right? Here we can have some examples which are not polynomial. Let's say we have this 1 divided by x. Or we can have x to the power minus 2. Or we have this root x. So these are not polynomials because powers must be 0, 1 or greater, right? It should not have negative powers. Only non-negative whole numbers should be the power. With the definition also we saw that powers where the exponents are non-negative whole numbers. So power should be 0 or greater. It can be 0, 1, 2, 3, 4, 5 or any power. And here for the algebraic expression, you should be aware about some of the terms which we use. So here let's take one example. We have this particular polynomial algebraic expression 3x square plus 5x minus 2. So here one important term you would be listening which is terms. So what are terms in the algebraic expression? So these sections which are separated by plus or minus are terms. Here 3x square is a term, 5x is a term, this constant is also a term. Apart from that, you will also listen about coefficients. This word also I have used with the polynomials. So here we have written this 3x square, where 3 is getting multiplied with this x square. So here 3 is coefficient. So the number which is attached with the variable, so it is attached with this particular x. So that's why we call this 3 as coefficient. Here this 5 is also attached with this x. So 5 is coefficient of x. After that we have one more term which is constant, right? Where you are not having any variable. And this operator you already know, plus, minus, multiplication or division can also be there. About exponents and powers we have already discussed that it should be 0 or greater than 0, right? It can be 0, 1, 2, 3 or any positive whole number. And now there can be different type of polynomials. There can be polynomials which are having one term only. And we call them as monomials. Because mono means single term. So some of the examples are 5x. So it is having one term only, right? Here we are having power because x to the power 1 is going to be x only. One more example is 7. So this is also monomial. Here it is constant. We are not having any variable. But here if you will think carefully, you can write any variable. Like you can write 7 multiplied by x to the power 0. And anything to the power 0 is going to be 1. So it is going to be 7 into 1, which is 7 itself, right? So that's why we have not written it, right? We need not to write x to the power 0 or any variable to the power 0. It is going to be 1 only. So you just need to write the constant like this only. And there can be one more example which can be 3x square. So this is also monomial. So it is a polynomial but with the one term. So all these examples are polynomial but with the one term. And as I told you that polynomial can have one or many terms. Let's say apart from these one terms we can have two terms. So that will also be a polynomial but it will be binomial. Bi means 2. So that's why we call them binomial. Like here we can have one example x plus 5. So here we are having two terms, right? This one and this one. Again we are having 2x square plus 3. Here also we are having two terms, 2x square and this 3 which is constant. Similarly polynomial can have three terms and we call them as trinomial. Tri means 3. So here we can have one example which is x square plus 2x plus 1. So we are having three terms now. One term, two term and three term, right? These are separated by plus symbol. So here we are having three terms, 1, 2 and 3. And these terms are separated by plus symbol. Similarly, we can see one more example, 2x square plus 3x plus 4. So here also we are having three terms. So like this, there can be 4 terms, 5 terms. So we are not having separate name for them, but you can directly call them polynomial. And here these are also polynomial, but we are having separate name for them, monomial, binomial and trinomial. And if it is having 4 terms, 5 terms, 6 terms, so you can simply call them polynomials. And about the polynomials, you should be aware about one more term, which is degree of polynomial. So the degree is the highest power of variable. Let's see some examples. So let's say we have this particular algebraic expression, which is binomial, or you can also simply call it polynomial. So x plus 5. So what is the highest degree? So here we have one variable, which is this x. And what is the degree of this x? Degree means highest power. So what is power of this particular x? It is 1, right? We can simply write it x to the power 1. So here highest power is 1, so degree will be 1, right? This one. Similarly, let's see one more example. So let's say we have this polynomial which is x square plus 2x plus 1. It is a trinomial, right? So here which variable we are having? We are having variable x, this one. And what is the power of x? It is having power of 1 here and it is having power of 2 here. And which is the highest power? This 2 is the highest power. So we can simply say that degree of this particular polynomial is 2. Now here let's see one more example. So now let's say we have one polynomial which is 4x to the power 5 plus 2x square plus 3. So now here what is the variable which we are having? X is the variable. And what are powers of x? The x is having power of 2. Also it is having power of 5. So highest power is this one, 5, right? So degree of this particular polynomial is going to be 5. We can also perform operations on polynomial. Let me show that to you. So here let's see one addition example. So we have two polynomial, let's say 2x plus 3. I am putting these parentheses so that you will be able to see two separate polynomials. And then we have one more polynomial which is 4x plus 5. And now we want to perform addition of these two polynomials. So here let's put plus. So now what will be the output? So we can see the similar terms. Which are similar terms? So we have this 2x and 4x. These are similar terms, right? Why similar terms? Because they are having same variables, which is x, and they are also having same power, which is power of 1. So now what we can do? We can write it as 2x plus this 4x. And now apart from that, we have these constant terms. These are also similar terms, right? Because they are constant. We can simply write it as plus 3, then plus 5. And now we can simply add these two similar terms. So these two and these two. So what it will be? So 2x plus 4x will be 6x. You can add simply 4 plus 2 and then you can put this x. So 4 plus 2 which is 6 and then x. And here in case of constant it will be 5 plus 3 which is 8. So you can put this plus symbol and then 8. And like this you can do the addition. Similarly we can have subtraction. So let's say we have two polynomials which are 5x plus 7. Let's put parenthesis here. And then we can have 2x plus 3. These are just simple example I am just showing you. You can perform operation on any type of polynomials. And here we want to do the subtraction. So minus. And how to do this subtraction operation? So here also we need to search for the similar terms. So here this 5x and 2x are similar terms because they are having same variable and same power. So now here we can write it as 5x, and here we are going to do the subtraction with this particular polynomial. So we are going to put this minus and then this 2x. And again we have these similar terms which are these constants. So here again also we can put them plus 7, and then this minus of plus 3 will be minus 3, right? You can simply say that you are putting this minus 2x and then minus 3. See, minus 2x and then minus 3. And now again you can do simple mathematics. So here 5x minus 2x will be 3x. So 3x, and then 7 minus 3 is going to be 4. So plus 4. So this is how we can do the subtraction. Similarly, let's say example of multiplication. So let's say we have one polynomial which is x plus 2. I am calling them as polynomial because they are having one or many terms. These are having two terms. You can also call them binomial. And then we want to multiply it with the other polynomial which is x plus 3. And it is not necessary that algebraic expression should be similar. Here the power can be different, variable can be different for different algebraic expressions, right? You should be able to do the addition, subtraction, multiplication, right? And now here we want to do the multiplication. X you can put here, or you can put them side by side. X plus 2, parenthesis, then x plus 3. And now how to do the multiplication? So now first take this particular term which is x. And now we are going to multiply this term with this particular polynomial, or this particular polynomial algebraic expression. So here if we will multiply this x with this x, what we are going to get? So x into x, which means x to the power 2. So here we can write x to the power 2. Now we can multiply this x with the second term of this expression. So here it is going to be x into 3, or you can simply call it 3x, 3 into x, right? So here we can again put plus and then 3x. Now the same thing we need to do for this particular 2. So here we can put a plus symbol, right? Plus and then 2 into x. So we can simply write 2x, and then we need to multiply this 2 with this 3. So it will be 3 into 2. So here we can write 6 simply, right? 3 multiplied by 2, which is 6. And now again we can simplify it. How? Because here we are having similar terms, because they are having same variables and same powers. So now what we can do, we can simply do the addition of these two terms. These are monomials, right? It is a single term and we are just doing the simple addition for them. So 3x plus 2x is going to be 5x. So 3 plus 2, which is 5, and then you can put x. So let's do that. So here what we are going to get, x square plus 3 plus 2, which is 5x, and then plus 6. So like this you can perform different operations on your polynomial algebraic expressions. And here for the polynomial section also, I have one assignment, which is this one. So here for this particular polynomial, which is 4x to the power 3 plus 2x square minus 5x plus 8, you need to find these answers. That what is the degree? How many terms are present? Is it a monomial, binomial, trinomial, or neither? So you try to find out these answers and let me know into the comment section below. In case of any doubt, feel free to reach out to me. And I have put all the questions related to the assignment for each section, which are equations, inequalities, and polynomials, here into this particular document. You can find all the questions and try to give me the correct answers for all these questions into the comment section below. And now we have learned all these things, which are equations, inequalities, polynomials, but actually where we are going to use them into the AI. Right now you do not need to understand the AI details. Just now where these concepts appear, you should be aware about that. So equations are used when models learn relationships between inputs and outputs. Then we talked about inequalities. So inequalities are used in optimization problems and decision boundaries. And then we talked about polynomials. So where these polynomials are used? So polynomials are used in curve fitting, feature engineering, regression concepts, optimization mathematics. Later in the linear algebra, calculus, machine learning, and deep learning, these concepts will appear repeatedly. So these topics are very important foundations. If you are not getting all these AI terms right now, so you need not to be aware about that. Whenever we will be using it, you should be aware that we already know about all these concepts. And guys, if you are finding this playlist helpful, let me know into the comment section below. And feel free to share your suggestions. I would love to hear your thoughts. And I would like to inform you one more thing, that you can support my YouTube channel. And for that, you can go to my channel WishInfinite and then click onto this join button. Here you can select the desired option to become a channel member. You can unlock exclusive perks while helping the channel grow. Your support means a lot. And a big thank you to everyone who has taken channel membership. As a token of appreciation, members can see their YouTube profile picture featured randomly on channel homepage here. Also guys, you will be able to find these playlists for the AI engineering, Python, mathematics right here onto my channel. Feel free to save these playlists for quick access in YouTube playlist section. And now I will conclude this video here, but before we wrap up, let me give you a quick recap. So first we talked about equations, where equation is a mathematical statement that shows two expressions are equal. So here we can write this x plus 5 equals to 12. So this expression should be equals to this expression, right? So that's why we are using this equals to symbol. And we can also solve the equation. For that we need to follow this particular rule. First we need to solve this add or subtract, then multiply or division, then exponents or powers, and then parentheses. So to solve this, what we can do? We can do this subtraction of minus 5 at both hand sides. And if we will do so, we will get value of x equals to 7. And like this, we saw multiple examples. You can go to this particular document, right? I will put all those things onto my GitHub. And here you will be able to see different examples, which we just saw, right? All the handwritten documents are available here for the equations. You can go through it with the videos. And in case of any doubts, just feel free to reach out to me. So now like this, you can solve your equations. You need to get the variable value. And one thing you need to remember, that to solve the equation, what you need to do? You need to keep the variable alone at one side. Then we talked about inequalities. So in simple word, inequality compares values. So on place of equal to sign, now we would be having greater than, less than, greater than equal to, or less than equal to signs. Like here, this is one example that x plus 3 is greater than 8. And like this, we saw multiple examples. And here, whenever we want to solve this inequalities and want to find the value of x, so we need to follow the same rule like equations, and then you should be able to get value of x. Here, one important thing we saw, that whenever you are doing multiplication and division with the negative number, so in that case, this inequality sign will get opposite, right? If it is greater than, it will be less than. And like this, if it is less than, it will be greater than. And same will be applicable for the greater than equal to and less than equal to. So there's a simple thing you need to remember, that you just need to reverse the sign when dividing or multiplying by a negative number. And this is very important, right? Do not forget. Otherwise, your whole equation will be wrong. And after that, we talked about polynomials. So polynomials are algebraic expression made up of variables, constant, coefficients, and powers. So this is one example of polynomial. Here these 3x square, 5x, minus 2 are terms. This x is a variable, right? Here. And then what is the degree of this particular polynomial? So degree is going to be 2, which is the highest power of this particular polynomial expression. We saw there are different type of polynomials. In case of one term, we are having monomial. In case of two terms, we are having binomial. In case of three terms, we are having trinomial. And in case of many more terms, we can simply call them polynomials. And now that's it from my end. You can click onto this first card to go to the next video. You can click onto this second card to access this whole Mathematics for AI Engineers course. And stay tuned for my upcoming videos. If you have any comments, questions, or doubts, you can let me know in the comment section below. Please like, share, and subscribe to my channel. Thank you very much. Have a great day.